So let me give you some background about A10. A10 as a company has a suite of application availability and application security products. One of our core offering is an application delivery controller, and an ADC is used to scale services horizontally. In the era of hybrid cloud, workloads move dynamically between the private and public clouds, and what is important is the associated automation lifecycle management capabilities that need to come along with it. So we need to, when we deliver application availability and security, this needs to be automated along multiple axes. One is orchestration across multiple operating environments. The second is provisioning of the network and service. And the third is discovery of services. So in conjunction with the tools and solutions from HashiCorp, we have built smarts into our product and internally use a bunch of their tools to automate our offerings from day zero through day end operations. So this not only includes leveraging Terraform, but also making engineering investments in Terraform and the Terraform provider and Consul. So a demo today will show how we leverage these tools to make offerings significantly frictionless for deployment and for day-to-day operations. What does multi-cloud mean? Multi-cloud just means that you have these tools and operations that smooth out the differences and abstracts the underlying environment. There are the operators have zero infrastructure dependencies on the application. And we have a software to manage large pool resources in a consistent, idempotent way, regardless of the underlying infrastructure. So this is where we use Terraform. On the next slide. Yeah. So given that HashiCorp's close ties with the cloud providers and the cloud providers' investments in Terraform, we could leverage a Terraform provider implementation to seamlessly spin up our entire testbed in the cloud. So not only do we work across multiple clouds, for our customers, we are basically we use these tools internally for our regression testbeds as well. Our solutions can be consumed as virtual instances of containers. So we've invested in Terraform for lifecycle management and bootstrapping for solutions on multiple public and private clouds. We picked Terraform as a tool of choice since it provides a homogeneous interface and decouples spin up of any infrastructure from the actual service provisioning. Terraform is based on a private plugin concept. The cloud providers have made their engineering investments in Terraform drivers, and they have provided drivers to return specifications. So we have built modules around these Terraform drivers, and this subsumes all the complexity about the cloud environment, and it removes the friction for users to spin up ACOS instances in any public or private cloud. The best part is that the deployments are repeatable and idempotent across any environment. It works across any of the major cloud providers like Oracle, Azure, AWS, Google Cloud, GCP, or a private cloud like VMware, OpenStack, or KVM, or even on a Kubernetes cluster. Again, to repeat, the deployments are always idempotent. The spin-up is an atomic operation. It either completely succeeds or fails, and if a failure is encountered at any step during bring up, all the previous steps roll back. So, and all the previous resources claimed are returned. So thus it's a all or nothing operation, which basically does all the heavy lifting of all the complexities associated with spin up in the cloud.
So moving on
the next slide. Yeah. So yes, the idea is that we have we support Terraform because it is very relevant in software-defined data center or any virtualized environment. Or again, you can completely decouple service provisioning from the underlying environment, and there's a service definition consistency. You can run it on any employment environment, be it testing, staging, or production. and there are no more artisanal scripts that someone is writing, and you just call the provider by Terraform, and it's intent based. You specify an outcome, and what happens every single time. Great.
Okay, shall we jump to
Yeah,
the
we can
demo?
go to the demo
Yeah.
of Terraform.
Okay, so thanks, Rishi. So to start the demo, so I'll first give a brief about what I'm going to do in the next 2 steps. So first of all, I'll be launching the A10 solution, ADC solution on the Proxmox setup, and then on the KVM setup, and using the Terraform as the tool, and the different providers. Like for Proxmox, we have Proxmox provider, and for KVM, we have the libvirt provider. We will use that to spin up the VMs in these 2 different environments, just to show you the quickness and the ease of commands that we need to spin up an instance of ACOS solution. Okay, so moving on to, so here I'm going to launch one of our new VM on the Proxmox setup. I will show you the current Proxmox setup, what all systems it has right now. So you will see in the logs here, as soon as I trigger the command from the command my CLI, it will start cloning one of the VMs from here. So that is the ultimate aim of my first part of the demo that I'm going to present. So to brief about the Terraform file here, what I'm going to, steps that I'm going to take is I'm using the Proxmox provider, as I mentioned earlier, and within the Proxmox, I'm spawning a new VM inside my Proxmox setup, and the template that I'm using is the one setup called ADI and vThunder. So this one. So standard Terraform commands, I will do Terraform inits to start with to install the plugins here. And after that, we can see the plan, what Terraform is going to introduce us in terms of the resources. So for that, I have already created a wrapper script that you can see here. You can spin up instance. So what this will do is it will init in every directory where you are going to execute this script, and it will show the plan also, feeding the values of variables. So as it is showing here, for now, we are going to create one resource, and that resource is going to be a VM itself. And to show, since we use a small profile.tf var, so it will give you the idea of what all resources and variables you want. So the prefix of my new Terraform, new VM would be VMTF, and memory I'm going to use 8 gigs and 4 CPUs and 1 count. So I will just straight away execute the script. Then I will move on to the KVM section. So again, this will do Terraform init, plan, and then apply. So all in one go. And as soon as it triggers here, you can see that it started cloning already. So it already logged one of the VM, and it started creating one. So we will let it go for a while. Then we will switch to the another KVM setup. So there we will try to create a new instance. Okay. Okay, so in similar manner, I have the libvirt provider here instead of Proxmox, and so simply here I'm going to just provide one of the template image that I have. So this is the template image of our vThunder, that is the ADC solution. And using the same image, I am going to do some cloud init. So cloud init thing. So that will create the host name as well and put some network configurations as well. And on top of that, I'm providing again the variable files, vThunder name and the vThunder memory CPU from the same variable file again. So it will show you that same different kind of variables files, those will be constant throughout the different solution. All you need to do is to mention the provider, and depending on the resource and what template and the values they want, then you can pass it using the variable file of yours. That is the same across the different solutions. So here I've again created a wrapper script, which is A10 spinner.sh. Again, I'll first show you the plan. So here I'm going to create 4 resources, and this includes the cloud init ISO image and the ADC image and the network resources as well. So right now, if you see, I'm going to use the medium profile dot variable file here. What this says is it needs a VM with 16 CPUs, this much of memory, and name as vThunder medium, and the other details that is required in the script. So right now there is no such VM created with the vThunder medium. I will quickly spin up one. Meanwhile, we can see in the Proxmox that it is still fetching the template and still creating the ACOS VM. And same operation is pretty quick here in KVM. So here you can see we have a vThunder medium VM already created, and it is up and running. So very minimal configurations required and very few commands, and you have a new VM with the required configurations. Console as well. So as soon as the VM is up, we can see the cloud init settings also being initialized here. And for Proxmox, which is still ongoing, as soon as the clone process is complete, it will create and as well as boot up the VM from the scratch. So, and whatever configuration is there in the clone VM, in the VM from which you are cloning from, you will see all the configurations being populated to your new virtual machine as well. So this is quick for our KVM solution. You can see the vThunder is up. It is still in loading state. The operating system inside our ADC solution is coming up. As soon as it is up, you will see the cloud init settings, and all the configurations that you wanted will be configured on the box directly. So to show you quickly what I am saying again and again why the cloud init configs is, I want host name to be some HashiTalk demo, and password as whatever I have mentioned in this file. Moving on to console again. So this one is still cloning, and so there are, multiple other things that I've mentioned while creating the instances, the network configuration, and all those things. So you will see whatever bridge configuration I have given in the file will come up here with the new VM.
So while this is getting created, I'll just bring out the virtues of Terraform again. It basically helped us with all the heavy lifting of bringing our solution in on any cloud consistently in an idempotent manner. And this is due to HashiCorp's incredible ecosystem partners, where each of them have invested in Terraform drivers. And basically, we could leverage that to kind of make our solution multi-cloud. So not only do we make a solution multi-cloud, we've also used it internally to spin up our own regression test beds. So because Terraform provides a homogeneous interface, based opportunistically based on whether we have some capacity on our on-prem hosts, or if not, we burst out into the cloud. So when we have to release something and we have a bunch of regression suites to kind of a full regression suite to kind of fire up based on the capacity we have, we can opportunistically spin up an entire test bed comprising hundreds of nodes locally or in the cloud. And this is, again, thanks to the incredible power of Terraform. The other investment that we have made and collaborated closely with HashiCorp is in the area of is in an upcoming product called network infrastructure automation. So as an application scales, and especially as a traffic load can be very seasonal and dynamic, the application scale, the service scales or shrinks. With the help of the network infrastructure automation console module, what happens is we can automatically commission or decommission nodes in the server pool such that the service can scale out and horizontally, and the service is very performant and always available. Now, under normal circumstances, this would be a manual ticket filed by someone when a node comes up. But given that this is a software-defined data center, this is software-defined or a cloud data center, automation is of prime importance. And this is where, again, the tool which HashiCorp has built, we are one of the first consumers of that, and it's going to be announced soon. Based on this collaboration, we can automatically populate the server pool such that the service is always available. It basically eliminates all operational burden by programming the backend server pool as a traffic grows or shrinks. And we do this just by this is done by the network infrastructure automation module. So this is another demo that Adi can demonstrate.
Sure. And just to show the completion of the first part, the Proxmox VM has been created successfully, and that we can see here in the Proxmox GUI as well. So the new VM has been created with the prefix of VMTF and the network devices as we have mentioned in the TF script. So yeah, this was to show the completion of the first part of the demo, and whatever we have mentioned in the cloud init, the host name and all these things for our VM has come up with the appropriate configurations. Moving on to the next part, as Rishi mentioned, the Consul NIA. So I'll show you first of all what services that I have in my Consul environment and what is the status, and on the fly, I'll change the status of these services from down to up, and we can see them being populated in the real time on our ADC as well. So going to CLI. Just to give the brief idea what I'm going to do and how I've configured the Consul NIA whole setup. So to start with, the Consul that I'm using is the setup that I just showed you, 1065.22.168.500, which is running here, and these services status are down right now, and those are done intentionally. And the Terraform driver that we are going to use is our own A10 Thunder's driver, and provider is again Thunder. Alias has been given Thunder 1. So with the help of the provider, we will be able to populate the services fetched by the Consul NIA to the vThunder, which is located on the right bottom screen of mine. The main part of this script is a task, which is basically going to fetch the services from the Consul setup, And it is using this repository of ours to match those fetched services to the particular template and uh, transposing that data to our uh, vThunder service list. So we have mentioned here using the provider Thunder TH1, which is the alias here. And the list of the services that we want to monitor is web, DB, and API, which are all here, API, DB, and web. So again, an easy command to start the Consul NI daemon. So right now there is no change in the resources. Everything is down right now. So I will bring up the service to introduce some kind of change in environment. So as soon as we see that something is changed, Consul NIA will report, and the configuration will be done on this vThunder settings. So I will bring up the services. I have written some wrapper scripts again. So now all the services, DB, web, and API are up. Consul NIA knows it has one resource that has to be added. So it reported it directly to the vThunder, which is located here on the right bottom screen. And as you can see, the API services and the DB service and the web service, we can match here 3 instances of API, 1 of DB, and 3 of web. And in web, we have 90, 90, 90, 91, and 92 port running. So 90, 91, 92 port running. So on the fly, we can see as soon as the services are up, we have the availability in the backend servers. So we configured them without any manual intervention on the vThunder. So these are basically the service pools. So as I showed you, those are populated dynamically, and these service pool we can map to the virtual IP. So that will basically keep on redirecting the traffic that is being hit on the virtual IP to this backend service pools. So again, to show you the completeness, I'll bring the servers down again and show you that how those are getting removed dynamically on this vThunder, on this ADC solution. So again, I'll just run a script to bring the services down all at once. You can see here, API, DB, and web all are down. So we will see something has changed. And yeah, on the right side, you can see now there is no section showing that there is any service group available. So the box for the ACOS or the ADC solution also now aware of that all the services are down and they should not be configured anymore on the box. So there should not be any traffic going on through the VIP anymore. So through the virtual IP.
It is a great demo. I think we're out of time. Again, thanks to HashiCorp. They have an incredible suite of tools which we could leverage and partner with, and basically make help progress a journey towards multi-cloud. Thanks again.